let's we begin with A. A can be written equal A tangent plus A radial. Okay. Here, in general, A tangent as magnitude equal dV divided by dt, and V equals to Vx square plus Vy square. A radial magnitude equal V square divided by the radius, and V square equal Vx square plus Vy square. And the magnitude of A, we can say A square or A equal the magnitude of A. You can say like this, equals to A tangent square plus A radial square. Okay, these are the numerical application of A tangent, A radial, and A. Sometimes you cannot calculate A. Here, you have to use Newton's law, F equal ma, for example, to calculate A. It depends to the example. Okay. Let's take a simple example. Here we have a center O, and we have a pendulum. Okay, the pendulum turns like this. Let's draw the trajectory of the pendulum. This is the trajectory centered about O. Okay. Here, I will choose any point. For example, I have this point. Here at this point, the velocity must be tangent on the trajectory. Let's say it's like this. So here V, which is tangent. As definition, V must be tangent to the trajectory. Okay, this about V. Any point you take, if you take this point, also V must be tangent. Any point here must be tangent, like this, at any point. Okay, let's talk only now about the point A. This is the point A. Now I want to draw the unit vectors. Here you have unit, we can say unit vectors in the case in the rotational motion. You have to use the unit vectors E, T, and ER. ET and ER, let's draw these two values. ET must be in the same direction with V. And ER must be opposite to the position of O. If here you have O, it must be opposite. And perpendicular with ET. Here we have E radial, and here we have E tangent. All the time, I take another position just to compare at this point. Here you have ET, and here you have ER. At this point, ET, ER, ET, ER. In the case, we are talking now about the clock. We have clock wise rotation. Okay, we are rotate in this. We have the rotation in this direction. Okay, very good. Now we have ET, we have ER, we have, okay. Second, the direction of AR must be in the direction of the center. O. At any position. So let's say here we have the black color for the AR. At this point, AR to the center. At this point, AR to the center. Also to the center. At any point, must be directed toward the center. AR, AR, AR. Okay, we don't need the black color concerning AR. Okay, and the most principal point, AR is opposite to ER. As you see here, at any point you have ER is opposite to AR. Okay, here we have ER, you have ER is opposite. These are the conditions. Now we are talking about the conditions of the E tangent and ER and AR. How can we draw each one? So these are the conditions. Now we have to talk about A tangent. A tangent. The condition is if the let's say speed V increases, so A tangent takes the direction of ET. If the speed V decreases, so A tangent takes the opposite direction of ET. Okay, it's clear now. With or opposite. Let's say in our example, it's a simple example because about the increasing or decreasing of the speed, it depends to the example. Here we have an example, a pendulum. This pendulum initially was at this point. I give a push. I push the pendulum at this point. The pendulum will start with initial velocity equal, for example, V initial equal to 10. As you know, when the ball goes up, the speed will decrease. Okay, we have 10, 9, 8, 5, 4. Maybe you arrive here at 2. It's not equal to 0. Maybe it's equal to 0, but I take the case where the velocity, the ball continues to move to the other side. So here we have the initial velocity, and between the bottom to the top, the velocity of the speed decreases. Okay? To arrive at the top of the circle where the speed is minimum. Now, let's draw here, here at the bottom, we have the position A. No, let's say here we have the position, we can say, let's say B. Here we have A. At the top, we have position C. Okay? We can write here between A, between the position, between position, positions A, excuse me, B to C, V or V decreases. Okay? When, as we said here, look here. If the speed decreases, so AT takes the opposite direction of ET. So at any point, so at any point between B to C, we are talking now clockwise, okay? We are talking clockwise يعني from B to C clockwise, not B to C anti-clockwise, B, C. So at any point between B and C, A, T, and E, T are opposite. Let's draw geometrically 80. So 80 at this point must be directed like this, at this point. So this one is 80, which is opposite to ET. If you take any other point, if you have here ET like this, AT must be opposite. At any point. Here you have the AT must be opposite to ET. Okay, excellent. Now let's take between the position uh, C to B. You know, from C to B, the speed will increase. Any ball, if you throw any ball like this at the highest position, it has a minimum value and it has acceleration due to the gravity. So the acceleration must be positive. So the speed or the velocity increases. So between this is let us say here, this is the first one and the second one, between positions C to B clockwise, the speed increases. We saw here, if the speed increases, AT takes the direction of ET. So AT and ET, they have same direction. Okay, we have same direction. Let's draw at any point, as you see here. Here you have, let's say this point. Here we have ET. So the speed must have the same, AT must have the same direction. And you know the speed also has the same direction. Must has. Okay. Here you have AT, the same direction like ET and like V. Okay. This is the general ideas about AT, about all these values. Let's calculate the Newton's law for in the direction of ER and in the direction of ET. Look, here, let's say we have an example. We can say here, okay. I take just one position. one position, we have the pendulum is at this position attached to a light string. Here we have the ball. This ball is like this. And here we have the weight of the ball. And here we have the tension of the ball. So here the tension and the weight. And let's draw, the motion is clockwise, okay? The motion is clockwise. And here, let's draw E tangent. We said it's opposite to the position of O, and E tangent has the same direction with the velocity. So here we have E tangent, and here we have ER, okay? And let's draw A. Here we have A radial. And you know, when the object, the ball goes up, must A tangent takes the opposite direction of ET because the velocity is decreases. فإذا here we have A tangent. Here we have A radial and here A tangent. ET plus ER, okay? T is in the opposite direction of ER. So it's in the ER direction. So we can put the magnitude in the direction of minus ER. Okay, we have only T in the with ER. AT or MG is opposite to ET. So we can have mg as magnitude with opposite with minus er, et. Okay, these are the forces equal m. Here we have at and ar. At is opposite to et. We write the magnitude of at equal dv divided by dt, but in the negative of et. Okay. AR is opposite to ER. So we write AR as magnitude, which is equal to V square. Here we have AR, okay? Which is equal to V square divided by R, but it's opposite to ER. Okay, now we take ER with ER, ET with ET. So minus T ER equal this one with this one equal minus V square divided by, we have M here, we have M. So equal minus M V square divided by R E R. You can write like this, or you can say, okay, you have here negative and negative. You can write T equal M V square divided by R. Okay, here, if you have T, you can calculate R. If you have R and V, you can calculate T as you like. You can say here, we have M V square equal Vx square plus Vy square divided by R. Okay, like this you can calculate any equation, any parameters any parameter as we like. Okay, now we take in function of et. We have in function of et, we have this one equal this one. We can write here, we can say minus mg et equal minus m dv divided by dt et. Okay, we can take out et, you can cancel et and at because you can put it in the same direction. We don't need to keep et, you can cancel it. So minus and minus, you get finally m and m also. So g equal dv divided by dt. Okay, here you have okay, maybe you have a v in function of the time t equal vx square plus vy square, and you can calculate it. It's okay. This is in the case if the velocity or the speed decreases. We take another example. In the case okay, we can take a point between C and B. Let's take a point here. We do the same calculation as a point here when the pendulum was at this position. So here we have ER, we have ET with V. So ER, ET. As you know, between C and B, the velocity increases, so AT has the same direction with ET. We can draw AT, it's AT, and we have also the speed in the same, or the velocity in the same direction. Here we have ET, here we have V. Okay, and let's draw here. Okay, we can write here AR and T. So here we have AR, here we have T, the tension, and also we have the weight of the object in this direction, we have mg. Okay, let's apply the Newton's second law. Summation of F equal ma. You know, we are working about the unit vectors et and er. What do you have? You have t and you have mg. Only these two forces equal ma. Okay, let's start with t. T is opposite to er. So we have the magnitude of t times minus er. Okay, mg is with et, the same direction with et. So we write the magnitude of mg with the positive et. Okay, with the same direction, equal m we have a tangent and a radial. A tangent has the same direction with ET. So we write the magnitude of a tangent, which is equal to dv divided by dt, the magnitude, with the direction of ET. And AR is opposite to ER. So plus is opposite, plus uh, the magnitude of AR equal V squared divided by R in the negative direction with ER. Okay, now we put uh, the value with ER together. Don't forget M, and also ET with ET. We have minus T, minus T. Okay, we can take off directly ER equal minus M V square divided by R. So T equal mv square divided by R. It's the first equation. You can calculate T, you can calculate V as you like. And the second one, you can write mg equal mg equal m dv divided by dt. So g equal dv divided by dt. I think it's clear, okay? It's all about a tangent, how you can substitute the value of a tangent, the value of a radial, how you can draw the direction of AT if V increases, if V decreases, all these parameters, how you can substitute, how you can calculate a tangent, a radial from the Newton's second law. I think this video is enough to explain all these questions. Thank you.